Hey guys, welcome to the second video of our MCP playlist, which is the only MCP playlist you are ever going to need. And in this video, we are going to build the MCP server, which I have showed you in the previous video. In the last video, we discussed the architecture of an MCP and the different concepts involved in it. If you have not watched it, please go check it out. So moving ahead, what we are going to build today is a local server which will expose three callable tools. If I show you an example, if I do a list tool, I can see uh, tools list, and by the end of the video server the MCP server can be rediscovered and called by a real MCP client workflow. There will be no resources prompt external API. I just want to make sure you understand the protocol mechanics first. Okay. And yeah, as I'm saying here, the point is not the business logic, it is discovery, schema validation, invocation results, and standard input debugging. So, standard debugging, and let's begin. So, the real question here is how are we going to build an MCP server? Are there any tools, are there any frameworks available for it? So, if you go to this website, modelcontextprotocol.io /docs/SDK, there are some SDKs which are available in all the languages you can think of. And in this, let's just, since we already built a TypeScript MCP, this time let's go with a Python SDK. So if I go ahead, you will see that this is the Python SDK. And if I go back here, if there a quick start, I don't see a quick start here. Anyways, let's go to this document. I want to make sure that you understand how I go through the document so that you can also implement the same thing and be self-sufficient and in navigating through the docs as well. So it says that they are building a weather server here as an example, and it says that you can import this user login.info, etc., etc., etc. So these are the steps for creating the virtual environment and adding the dependencies. So these steps are going to be common for us as well. I have a new folder here which says MCP course, and in this I'm just going to do a UV init MCP course. This has been added. Let's go to this MCP course, and here it will tell you to create a virtual environment. So we are just going to create, just go to uvnv dot vnv slash scripts slash activate. Then it is going to tell you to add the dependencies. So uv add mcp cli and httpx. I'm not going to add httpx yet because I want to show you how this works in the standard input, and then we are going to move to httpx. So for building this, it says to import any, import httpx, import fast mcp. So this SDK which is there, in that there is another portion in which it helps you create a lot of things very fast. And this is basically, if you go to fast MCP, or if I go to fast MCP, so there's a fast MCP quick start example here which we can use. Just you just need to do MCP, create fast MCP, give the name, the JSON response, and the other parameters, and it will create it for you. It's just a one line of code. So yeah, that is how it is easy with SDKs to do this. So let's create a fast MCP and add a tool as well. I'll copy this and let me copy the whole thing, and then we'll just delete what we do not need. New file. It has already created a main.py thanks to UV. Let me just paste everything here. So it says fast MCP. Okay, we did not import fast MCP. Importing fast MCP. The next line, MCP, and we don't need this. We don't need this as well. Okay. Type of MCP is unknown. This is by pylons. I think for now I can disable pylons because it is going to give a lot of errors, and if I keep solving them, the demo will become a bit complicated for now. So all I need to do is simply disable it from here, restart the extensions. Okay, and let me go back to my main.py. Let me just do a UV run. Okay, sorry. Yeah, UV run python main.py. So you would see that the application server it has started, but this was in streamable HTTP. But what I want to actually show you here is the first transport layer, which is STDIO. So if I see here, I see the option for STDIO. I can just change this to STDIO. Now, if you run the server, you will get nothing. And why is that? This is basically because when you are running STDIO, you have to run it from inside the MCP client. Otherwise, it will not be able to like get the input and output. So this is basically just a dead process. Let me close this. Now, we want to use this MCP and see how it is working. So for that, the most obvious option would be just add it to a coding assistant CLI or maybe an agentic app and run it. But that will become too complicated. And also, there's one big concept which I want you to understand. It is that the MCP part and the LLM part, these both are completely separate. Like MCP server can exist without an LLM and function completely normally. Like all the tools can be called just like simple HTTP request, even without the LLM. So why do we link it? We link it simply because whenever you use some coding agent like Claude, Codex, or maybe you have an agentic app, you want to have more context, so you use the MCP. But why just the MCP is because, as we discussed in the previous video, it is the standard protocol to connect both of these together. Hence, we use an MCP. And now in this video, I'll first show you how you do it without LLM. How do you know your MCP server is running perfectly well? Because as I said, it does not need an LLM, so we need a method which does not use an LLM, and the best way for it is to use something called a MCP inspector. So if you go to this repo, this is a very popular repo, and you just copy this command here, just paste it here. It will start a Node.js app, and if you copy the URL from here, paste it in your browser here, you will see this opens a new browser tab, and it's basically a local website for NCP inspector. Is just a front end. And now what you have to do is, if I just reset all of this, yeah. So when you open it first, this will be the default configuration for you. Just select stdio from here, and it will ask you to give a command and arguments. Now, as I said, like if you are switching to streamable HTTP, it is asking for a URL. If you are switching to stdio, it is asking for a command and arguments. Now, what will be the command? So, since this is a Python app and you are using a virtual environment, simply what you want to add is the python.exe. You will just copy the path, paste it here, and in the arguments, you would add the like path of your main.py and make sure you put it as a string. Now, if you click connect here, you will see that it shows connected. Now, this MCP inspector app will help you get a broad overview of what is there in your MCP. So, as we discussed, things like resources, prompts, tools, even apps, and a ping, these are all the things you can do with your MCP, even auth. And make sure you watch the auth video, which will come later on because it is really like the concept which I'll be explaining will be really useful in a lot of other places as well. So let's get back. You see the tools here. Now, if I do clear and I do list tools, you will see I get a tool as add. If I click on it, it will tell me to give the inputs. So the inputs I have, it is A and B. And you would see that it says that you can add two numbers. So let's just give 2 and give 5 here. Let's run the tool. You will see that it gives me the value 7. So, uh, okay. And let's connect it again. My bad. Yeah. And if you see in the MCP, what you will get is that you received a post message for the session ID. It went to the MCP server and then did the calculation and it just showed you the result. So you have created till now your first MCP application within minutes. And now we will create what we actually intended to, which was these specific tools, which is calculator.add, time.now, and project.get status. So if I create, if you notice that to create an MCP tool, so all you need to do is just annotate it with a decorator for the MCP tool, and then it will automatically get picked up by your MCP server. So if I just create another tool, so I have already created the add tool. If I just create time now, and over here time dot now, I think it just, oh, it was date time. So we are going to do from time import date time. This should get imported properly. No, oh, I think it's just import date time, date time dot date time dot now. And what does it say? That it returns a new date time representing current time local to TZ. So you are just going to return the date time. Now, if you go here and then you do a restart, and then you do a list, clear this, do a list tools. Okay, we did not add the decorator yet. So just paste it here, go back, do a restart, connect again, go to tools, clear list tools. So you see that you get the time now. And if you just run this tool, it will return you the current time. But you need to also add the description. So the description is whatever you add in the doc string over here. Returns the current time for the server. So this is basically possible just because of the fast MCP implementation we have here. Um, Otherwise, it would actually have been couple of lines of code, but only because of fast MCP, you can just simply do it very easily. Now to add the get project tool, what I am going to do is I can just copy this and I'll paste this, and I'm going to do a get project status here. And for example, I have here project details, and what this has is basically like a name, it has project one, and then it has just a ID, and ID, it is, for example, it has a ID of 5, and then it has a status. So the status is basically completed. Let me just have a single project to make it even more simpler. And this is going to be a here, and get project return project details, and you just return the ID, but the ID should come from your ID ID. Okay, so now let's run the tool again. Let's restart the server. Now I go to tools, I clear this, do list tools, ID I give 5, error executing, get project status 50. It's going as a string here, but it is actually, okay, so this ID here, if it is a string, only then we get it. Return project details ID. No, this is actually going to be, we need to find the project details from here. So this can be multiple projects, and in this one, we'll do a correct project equal to mm, for correct project for project in project details project uh if projects ID equal to ID, then correct project equal to project, and you do a break. And over here, you just return the correct project along with the status. So you disconnect it, connect it again, restart it, go to tools, clear list tools, 5, run it, error executing at project tool, status. Okay, if I go here and this takes the ID, oh, this comparison, it's not correct. It actually needs to be against an integer since we have the ID as an integer. Then we can go here, restart, connect, tools, list tools, get project status, ID 5, and you see the status as completed. So now you have all the three tools implemented. So let's go back and you would see that the point is the discovery, the schema validation, invocation results, and the standard input IO. So that is what we have discussed in this video. And every local tool follows the same server loop, like it creates the server, registers the tool, attaches whatever protocol it needs. You can inspect the tool after this. So that will happen when we connect to it to codex or client, configure the host using the command and the arguments, and then you can get the output. So like the server entry point, like this is a sample which you can use and replicate this in a TypeScript project, and I do leave this to you. Otherwise, I'll also attach the code in TypeScript in the description or maybe in the comments. But the main takeaway is that a tool is a contract, not just a function. So it has a name, a description, input schema, handler, and result. If you go here to this decorator MCP tool, you would see that it actually expects a name, title, description, annotation, icons, and also the structured output. So it says the decorator to register a tool. Tools can request a context object as well. And these are all the arguments. Some examples also you will find here. So in an actual system, it is highly recommended that you add all of these extra parameters which are there in the annotation so that your tool it's more like cohesive with the end user, cohesive for the end user. And so the transport layer is what converted it into a local MCP server. This is what you would use in TypeScript. Again, I'll highly recommend you do it yourself so that you understand. You have to do very little steps. Like you can just go to here, go to SDKs, and you would see TypeScript. Just open it, or even you can go to here and connect. Sorry, develop with MCP, build an MCP server. The same page we went before. It's open here, and then you can just select um, TypeScript and follow the same steps to basically build your first MCP server. And inspector, it's basically like a test bench which you are using. It gets the connect, the tool, and the notifications as well, so that the whole validation loop is correct. The host launched the server with the command plus argument. So these extra slides are just make sure made to make sure you understand the whole steps properly instead of just having an abstract idea. And now you have the smallest useful MCP server. The server ID is created, tools are registered, STD or transport is connected, discovery and invocation verified. In the next video, we'll use the same pattern to build a real GitHub PR assistant server. And maybe we can add API authentication, pagination, and read-only tools in the upcoming videos. So yeah, thanks for watching and do drop a comment with any suggestions. Yeah, see you in the next one.